Okay, here this is the lesson number walking through the problems. Let me check the IM. So this is lesson number 14, algebra 2. What do you know about polynomials? How do the polynomial graphs looks like? What is the meaning of zero? So the let's put together what we have learned about polynomials. I can use division to rewrite polynomials. अरे अबे मैं इधर This lesson is I can use division to rewrite polynomial in factor form, starting from a known factor and then sketch and what it looks like. So I will dive down directly to practice problem, and that is the very first one, lesson number 14. So first problem is we know these things about a polynomial function f of x, and what is given it has exactly one relative maximum, something like this. That's the relative maximum, and one relative minimum, something like this. And it has exactly three zeros. So that means if there is a graph somewhere, something like that, it goes three times, one, two, three, or it could be also this way. So it depends on the leading uh, term, plus or minus. Now, and it has known that this is a factor. Now, knowing this x minus 1 is a factor, it means we want to know when is this equal to 0. I'm just showing the steps. It means at x equals 0, there is a 0. That means the graph goes to this point. Now, how do I sketch the other information? So all you do is you can either I can now remember I can either have this graph. If I want to have this graph, I can just go up like this, pass through this, and I can do two curves. That's the relative maximum and that's the relative minimum. And you have three zeros. Not just this, you could also have with the same four, let's see, four here, this is one. You could also you could also do this way and go like this. See? So still there are three zeros and x minus, and 4 also is a 0. That's why x minus 4 is a factor. This also is correct. Or you could also write 4 here. This could be 4. And you can also do going this way also. See? This also is correct. So different ways to show. And there's another last way I can show you is one more. If this is 4, uh, I can also go this way and one fact like this. That is also. So as long as you have, but this, if you do this, there will be only two zeros. That is, yes, sir. Yeah, I'm showing. Oh, no, I don't want to. So this part will be, this will mean it has two zeros. That means 4 is repeated. So this is not exactly 3. They want exactly 3. So this will be wrong. So at the most, what you can do is just go this way, this way. Okay. So I think it's almost the same thing. And I got the point. Let's go to the next one. And the second question is, my graph's a polynomial. F of x has three linear factors, so they are given three. What? But she makes a mistake. What her mistake in graphing? So if you see the graph, what is her mistake? Now, when you have these three factors, it means the polynomial is x plus 6 in factor form, x plus 2, and x minus 1. So this, if you want to make it equal to 0, you want to know when is the output 0 because it's like output. So for what x is, it has to be the opposite of plus 6 because minus 6 and plus 6 only is 0, right? So the answer for x is minus 6. And here x has to be minus 2 because there is a plus 2. And the third one is if it is minus 1, it has to be plus 1. So basically the graph should have gone through minus 6 and minus 2 and plus 1. So it should have been this way. This should have been the graph. So that's the mistake. So she forgot to change the signs of this number, and instead of plus 6, she took exactly 6. So you have to write the opposite of that. So here is a graph of a polynomial, and it has a degree 4. So the way it is given, it means it has a degree 4. That means x, 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 and x. Then what are the zeros? So select all the statements that are true. So whatever is given here, first of all, there are exactly four zeros, and you can write this as opposite, which is +4, because if this is -2, you write +2. If this is 2, you put -2, and this 6, put -6. So this is the polynomial. Then you also, what else is true? It has one relative maximum. Look at this, is relative maximum, or it is also called local maximum. And okay, so there are two values here. So there are two local minimum. That means there are two relative minimum. And what is the end behavior also? As it is, end behavior is goes plus infinity. Either the x becomes goes to minus infinity and x approaches plus infinity. The y value will always be plus infinity straight up there. So that's all they're asking us. And one more observation you have to see is also that it has a constant term, is the constant term here, the graph that crosses the y-axis is we don't know what is the number. Of course, we can easily figure out by just multiplying this 4 times 2, which is 8, and -2 times -6 is 12, and this is plus 96. So that's 96 right here. So the constant term is positive. The leading coefficient, uh, so this one, the leading coefficient, if you multiply all this x, it is plus x squared. So that's positive. And that's why you see the graph is up. So I hope this helps to figure out exactly which one to pick. Now this question, state the degree and end behavior. Explain or show your is. Now if you look at this, the leading, the now the end behavior is always depends on the very first term, and this is the leading term, which is 2x cubed, and it is positive. And because it is positive, the graph will look this way, down, up. So this is down, and this is up. So this is how we know. And the end behavior will be, it means something like, see, this graph is the end behavior, and I can draw the x-axis and y-axis. So when x becomes very large positive value, the output, so this output goes to, so the y value becomes plus infinity. And when x becomes very large negative value, the output, so it means when x approaches very large negative value, the y value will approach to very large positive. Again, sorry, large negative value goes down. And that's the end behavior. And the degree is 3. Degree is 3. And that's why this is the shape. Or it can be like this also. But one thing, it is down, up, and it is odd. So whenever it is a degree 3, which is odd, it has to be down, up. Now, if you see this, they gave you this graph. So the question is, the graph that is given, which one is the graph? If you see this, at -2, it crosses, right? That means the factor will be x plus 2 with the multiplicity 1. But at 1, there is a turning point. So on either side, the output is positive. So it means that +1, opposite is -1. And because it's taking turn, okay, so it has to be 2. And the reason is both this they give us, if you see this, this is 2 and 1, which is 3 degree. This also is degree 3. That means if one of them is 1 here, the other one has to be 2. So this is the correct answer. So the one that they gave us is, so x plus 2 should be 1. So this is the correct answer. And that's the explanation. A student, he thinks that he knows one of the factor of this polynomial, which is he thinks he knows one of the polynomial for this. After finding p3, so he gets p of 3 is 0. Kiran suspects that x minus 3 is a factor. So he lets the diagram to check. How do you reasoning? He says to check. He does something wrong. What went wrong? Now remember, if x minus 3 is a factor, because What does this basically means? When x and y, that is 3 comma 0 input output. So when x is 3, the y is 0. That means x minus 3 is one of the factor. Now you want to figure out the box here. When you make a box like this, the factor has to be here x, and it has to be exactly written minus 3 here. And this is what you want to figure out. If you want to find the quotient when this is one of the factor, that means you have to write this. You need to figure out. That means if this is x cube, put a x cube here, and if that is then the rest follows, right? So this time this becomes, and then minus 3 times this becomes minus 3x squared. And what adds to here to get you plus x squared, and it has to be plus 4x squared. And then you put x times 4x here, and then minus 12x, and then ask a question what adds over here to get minus 17, and you can see the only way it is minus 5x, and that's how you figure out x times the minus 5 will give you this, and minus 3 times minus 5 will be plus 15. So this is how you're supposed to do, and you get the answer as this one, which is x squared plus 4x minus 5, which can further write into two factors, because the factors of 5 is 1 and 5, and this is minus, so when you subtract you have to get a 4, but this is already plus 4, so big one takes plus, the smaller one takes minus, and the answer is plus 5 and minus 1. So what does this question says is, you are given a polynomial and one of the factor is x plus 2. Can you rewrite as product of linear factor? That means we need to have three factors like this, x, x, and x. So this is bx. So one of the factor is given x plus 2. So we can use the one that we use is a synthetic division is the fastest way to do, the one that we were doing. So put a line, and you can see the coefficients of the x's are 1, and plus 8, plus 5, and minus 14. So this goes 1, 8, 5, and minus 14. Now if this is plus 2, so you have to put opposite, drop down the first one, and then start working on negative 2 times this will be negative 2, together will be plus 6. Then you multiply 6 times 2 is minus 12. So this will be 5 minus 7, and then you can see minus 2 times minus 7 is this is 14 here, so plus 14, and this together is 0. So there you go, the remainder is 0. What is 0? That means this one is a factor, but then the main numbers are these to create a quadratic. So first is the bx that we have is the first factor is x plus 2, and the other factor, which is also the quotient when divided by x plus 2. So this one, so it is 1x squared and plus 6x and then minus 7. So this is the actually the quotient when you divide this polynomial by x plus 2, which we can further factorize into two more factors, x and x. And now, how do I split? There's a minus 7 here, and this is 1, so you split minus 7 is 1 and 7, and you need to when you subtract, you should get plus 6. You should get 6. So to get 6, the only option is the bigger one has to be positive, and the smaller one has to be negative, smaller one positive, and you get minus 6. So that's why we use minus 7 and plus 6. So minus 7, sorry, the big one takes plus, the smaller one takes minus. So this will be plus and minus 1. And there you go. So the zeros are opposite of plus 2 is minus 2, opposite of plus 7 is minus 7, opposite of minus, and you're done. So I hope this takes care of the first two pages of the packet, and the rest we'll do tomorrow.